Now in this part of the question we have our curve C, which has the equation y equals e to the 2x tan x, and we're asked to find the equation of the tangent, an equation of the tangent anyway, at the point where x is 0. So how are we going to do that? Well, basically what I'm going to be doing is, because the tangent is a straight line, any straight line, remember, is of the form y minus y1 equals m bracket x minus x1, where x1, y1 is a point on the line, and I already know that the x1 coordinate is going to be when x is 0. What I need to get is the y1 coordinate, and I also need to get the gradient at the point where x is 0. And the gradient can be achieved by differentiating our equation here, which in fact we did in the first part of the question. Okay, so that gives you a little bit of an introduction of how I'm going to do this, and let's start then by finding the corresponding y1 value when x is 0. So what I'm going to do is say that when x is 0, we can see that if we substitute it into the equation up here for y, we're going to have y equals e to the power 2 times 0, which is e to the power 0, and then the tan of 0. Now e to the power 0 is 1, but the tan of 0 is 0. So what we have is that y is also equal to 0 when x is 0. So the tangent then passes through the origin. So what I've got so far is that I now know that y1 is going to be also equal to 0. Now we need the gradient, and as I said earlier, we can get the gradient through differentiating our equation up here. But from the first part we found that dy by dx, if you go back and have a look, you'd see that we worked it out to be e to the 2x sec squared x plus 2e to the 2x tan x. Now then, what I need to do is say what dy dx is, the gradient, that is, when x is 0. So when x is 0, we have that dy by dx is going to be equal to e to the 0, which is 1, multiplied by sec squared 0. I don't know what that is at the moment, so I'll just hold that back. And then I have plus 2e to the 0. Well, e to the 0 again is 1, so that's just going to be simply 2 times 1. And then we have the tan of 0. So, what is sec squared 0? Well, sec squared, if we just come up here, or sec, should we say? No, let's go for sec squared. Sec squared x is the same as 1 over cos squared x. So therefore, sec squared 0 must be 1 over cos squared 0. Now, the cosine of 0 degrees or radians is always 1, and so therefore we've got 1 over 1 squared, which is 1. So over here we've got 1 times 1, which is 1. The tan of 0 is 0. 2 times 1 times 0 will be 0. So we've got the gradient then is 1. So we're on the last stage now that we can say, let's just draw a line down here just to border this off. Normally what I write would be underneath here, but because I'm short of space I have to say that therefore equation of tangent, it's always good to give an introduction to what you're doing, at x equals 0 is Try and avoid writing equals. It's a very common mistake. And what we've got is y minus y1, which y1 was 0, remember, equals m, the gradient, which we've seen over here, is 1, multiplied by x minus x1, and x1 was 0. I know I didn't have to write those zeros in, but just decided it would be good to follow that particular structure there. So therefore we have y equals 1 times x, which is x. So you can have y equals x then, or anything equivalent to this as your equation of your tangent. You know, like y minus x equals 0, for instance, would also do. Okay, so that brings us to the end of this part of the question. Well, in fact, to the end of the question completely. So I hope you've been able to follow that, and great.